I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to see the topic on optical fibers and devices, propagation of light, and also optical fiber structures. So, the topic we have taken is optical communication, a very important type of communication for long distance transmission, which provides higher data rate and also higher bandwidth. We know communication is the transfer of information from one point to another, and communication system refers to transfer of information which is achieved by modulating the information onto an electromagnetic wave which act as a carrier for the information signal. So the electromagnetic carrier is selected from either radio frequencies and or microwave and millimeter wave frequencies or optical range of frequencies. And the limitation here is the information carrying capability, and this information carrying capability is proportional to the bandwidth of the channel. And the radio communication system is the information modulates a high frequency carrier and information carrying capacity is increased, bandwidth of the channel increased, and we can decrease the, and here available spectrum space is decreased. And if we take the microwave signal, it is used for higher frequency carriers, that is 1 to 300 gigahertz, and the cost of the equipment is high. But if we use the communication by light, here light acts as a transmission medium, and the electromagnetic wave carrier optical range of frequencies 1.76 pHz to 3.75 pHz, and communication of optical wavelength is 800 nanometer to 1700 nanometer, and it offers a increase in bandwidth by a factor of 10 power 3. And if we see the general communication system, we know it consists of an information source and a destination. In the middle we have a transmitter and transmission medium and a receiver, and this is optical fiber communication system. And here in this case, in the case of optical communication, we have information source, next the electrical transmit, and the electrical signal is converted by the optical source, and optical fiber cable is having used as a medium. And after that, at the receiving side, we need a detector to detect the light signal, and again this light signal is converted into electrical signal in order to understand by the receiver, and it is transmitted to the destination as a original signal. And if we see the optical fiber communication link, it consists of at the transmitting side drive and a light source, and we have a fiber flyleaf, and optical splicing whenever we need it can be given. And at the we have a regenerator in order to boost the signal amplitude, and it consists of an optical receiver and the electronics part and optical transmitter. And at the receiver side, we have photo detector for detecting the signal, and amplification is done, then the signal restorer is given, and we get the original electrical signal. And this is the optical fiber communication link. And in this diagram we are going to see the digital optical fiber link, where we have an encoder and at the transmitting side, at the same time decoder at the receiving side. The encoder encodes the given information, and we have a laser drive circuit after the encoder, and the laser is given as a light source, and transmission medium is a fiber cable. At the receiving side, we have a avalanche photodiode or any type of photodiode for receiving the signal, and after that we amplifier and equalizer is there, decoder for converting the original signal, and we get a digital output. So this is digital optical fiber link. So optical fiber, we can define it as a dielectric waveguide, and it operates at optical frequency. It is in cylindrical form, and modes of the waveguide, the propagation of light along a waveguide can be described in terms of a set of electromagnetic waves These guided modes are referred to as bound or trapped modes of the waveguide. And the fiber structure consists of the two important parts. One is a core and another one is a cladding. So core is a single solid dielectric cylinder, and consider its refractive index is N1, and the core is surrounded by another type of structure called cladding. Cladding refractive index is taken as N2, where N2 is always less than N1. Here refractive index difference is needed so that by the use of total internal reflection, the signal get propagated from one place to another place inside the fiber. And after that, there is a buffer coating in order to give further strengthening of the cladding, and this is consists of elastics, absorption resistant material. And cladding is needed to reduce the scattering loss and also provide mechanical strength to the core and protects the core from absorbing surface contaminants. And features of this optical fiber communication: it provides higher bandwidth, small size and light, electrical isolation is provided because no electromagnetic interference, and immunity to interference and crosstalk, signal security, and because no leakage, and low transmission loss, ruggedness and flexibility, system reliability and ease of maintenance, potential low cost point to point communication. So these are, because of these very attractive features, optical fiber communication is now used for high signal transmission, high frequency signal transmission. And if we see the applications, optical fiber communication is used for long distance communication as a backbone and inter-exchange junctions, video transmission, broadband services, computer data communication, military application and non-communication applications, etc. And fiber types, there are two types. One is step index fiber and another one is graded index fiber. And these two classification is done because of material composition of the core. So in step index fiber, the refractive index of the core is uniform throughout and undergoes an abrupt change at the core cladding boundary. And in the case of graded index fiber, refractive index of core is made to vary as a function of radial distance from the center of it. So, and also based on the type of modes, it is referred as single mode fiber and multi-mode fiber. And these are the comparison between single mode and multi-mode fiber. The most important comparisons are core radius of single mode fiber is small, but in the case of multi-mode fiber, core radius must be high in order to allow more number of modes inside it. And single mode fiber support one mode of propagation, but multi-mode fiber supports hundreds of modes. Optical source used in single mode fiber is laser, in multi-mode fiber it is LED. And the launching of optical power into the fiber is difficult because of the small core radius, but in the case of multi-mode fiber it is easy. Launching of optical power into the fiber is easy and supports larger bandwidth, but multi-mode fiber supports lower bandwidth. Single mode fiber, the intermodal dispersion is but in the case intermodal dispersion is absent because it consists of only one mode, and in multi-mode fiber there will be intermodal dispersion. And single mode fiber is useful for long distance communication, but multi-mode fiber is used for short distance communication. And these are the optical fiber structures: step index, graded index fiber. And assessment. So multi-mode step index fiber has a large core diameter. The range is asked. The answer is 100 to 300 micrometer. And single mode fiber allows single mode propagation. The cladding diameter must be at least, the answer is 10 times the core diameter. Thank you.